Good morning, students. Am I audible? Yes. Am I audible, students?
Yes, ma'am.
Okay, thank you. Let us wait for 2-3 minutes. Till that time, just tell me whether the slides are visible to you. Okay. Slides are visible?
Yes, ma'am.
Okay. Okay. So let us start. Still only 41 students have joined, but do not wait longer. So let us start with lecture. So in yesterday's lecture, we have seen this regular expressions are used for specifying the tokens. So always remember, to specify tokens, we need the regular expressions. And to recognize the tokens, we need finite automata. So yesterday we have seen the example of finite automata. We have started with very basic example of making the switch on and off. So two states we have considered, on and off states of the button, and push is the operation or input we are providing to it. And it has two states. Q0, that is initial state, is off, and by pushing the button we are reaching to the on, which is your acceptance state. And we have seen with the given string of 3 times push operation, the string was acceptable. That means the job of finite automata is to check whether the given string is acceptable with respect to the regular expression or not. So it is the job of the finite automata, and that's why to recognize the tokens, for recognizing the tokens, we need finite automata. So that is the very basic thing. So it may be there in the MCQ type of questions, like for specifying the tokens, we need dash dash, and for recognizing the token, we need dash dash. So for specifying tokens, always remember regular expressions are required. And for recognizing the tokens, always finite automata is required. Okay. So uh, we have seen the finite automata for the comment in the C programming. So it is starting with multiple line comments, obviously this is. So slash star, and it should end with star slash. If it is there, then only you are reaching to the acceptance state. If any of the construct is missing, then you are reaching to a non-final state, giving you the error that token is not getting generated. So whenever you are reaching to the final state, only that time the token gets generated. Otherwise, you will get the error. Okay. So let us see what is the formalizing automata behavior. So for that, we should know that how to convert the NFA into DFA. So for that, we will study some part of the already you have studied the theory of computation subject, in which the conversion process is there. That is how you are converting the NFA with null or NFA with epsilon transitions to DFA. So basically the finite automata is divided into two types. So all of you are aware that the finite automata is used for token generation, and it is divided into two types. One is called as DFA and other is called as NFA. Okay. So what is the DFA stands for? DFA stands for deterministic finite automata. So what is the meaning of a deterministic finite automata? So the finite automata has number of states and number of input variables. Like we have seen the example of on and off state, right? So I will draw that example again. Suppose this is your state number 1, which is your initial state. And with one input, you are reaching to the second number state. Wait a minute, students. Okay, so here with one input, let's say yesterday we have seen the example that from starting state we are reaching to the final state with some input, let's say A. Now, whenever with single input variable, we are reaching from one state to only one state, that is 1:1 ratio is followed. From single state with single input symbol, we are reaching to single state only. If this is the process, then it is the example of DFA. And if I'm having one more thing, that with A, I'm having the second transition possible. Here you can observe with A, already one transition was there, that the transition from 1 with A, I am reaching to state number 2. But now I have introduced one more transition with A. So the second transition of 1 with A is 1 itself. Now there are two ways or two transitions possible from state number 1 with input variable A. So if 1:2 ratio is maintained, that is from one state we are reaching to two states. One is A and other is, one is state number 1 and the state number 2. So if this is the example that with single variable we are reaching to multiple states, then it is called as NFA, which is non-deterministic finite automata. The name itself gives you idea now that the state is not fixed. State is not deterministic or fixed. And that is why it is called as non-deterministic finite automata, because with A, I may reach to 1, or with A, I may reach to 2. So the path is not fixed one, and that's why it is called as NFA, non-deterministic finite automata. And earlier example, when this transition was not there, With A, I was reaching to only one state, which was your deterministic finite automata. That I am knowing with single variable A, I am reaching to only one state. So that was called as deterministic finite automata or DFA. The second thing is NFA may have the epsilon transitions or null transitions. NFA may have null transition. What is the meaning of null transition? So null is acting as an input. Here from 1 to 2, if I want to move from state number 1 to state number 2, I need variable A as the input. If a variable input is not provided, then I may not reach to state number 2. Is there any difficulty? Students whose mic is on. Arbaz Mujawar. Kindly check your mic, students. Okay. So, okay. So here, if I want to move from state number 1 to state number 2, I should use variable A as the input. Then only it is possible. But in NFA with null transition, there are some null moves. What is the meaning of null moves? That without any input also we may move from one state to another state. If null variable is acting as an input, that is no input is provided, then also the transition is possible from one state to other state. And that type of transition is called as epsilon transitions, and they are present in the NFA. So these are the two main differences between NFA and DFA. So if I'm using this null transition, the design of finite automata will become easy, isn't it? Because I may move from any state to any state with null moves. So it will give me free movement kind of thing, that I can jump from one state to other with absolutely no inputs, with null inputs, right? So this drawing NFA is very easy. So I can say it is very easy that I am going to get the finite automata. If I will draw NFA, then the process is easy, because with null transitions are available with me, and I can move from one state to other with null transitions easily. So drawing NFA is easy, but drawing DFA is difficult one, because you have to take care about the proper input variable, small a, small b, and whatever. So that is, drawing of DFA is very difficult because the path is fixed. If you are going to change that, then it may give you some other finite automata. So the required finite automata will also get changed. So that is nothing but the drawing of NFA is easy and DFA is difficult. So what we are going to do is, whenever I want to draw any finite automata, I will draw NFA first, because it is easy for me. Suppose the regular expression given to you is, let us say A followed by A or B star. Okay, so this is the expression given to me. Now for this regular expression, if I start drawing DFA, it will be difficult for me. So what I will do, I will draw NFA for it, because it is easier. So I will draw NFA for it. And now every NFA can be converted into its equivalent DFA with our algorithm, which is called as subset construction algorithm. So now my job is, I will draw easy NFA, and then by following just the steps of the algorithm, I can convert it into its equivalent DFA. So that ultimately I am going to get DFA, which is deterministic finite automata. It has a specific move with specific input variable. There is no non-deterministic nature. Fixed nature is there or fixed paths are there for specific input. Okay, all of you are getting it. Why there is need of drawing NFA, why there is need of converting it into DFA. Is it clear? Yes, students? Is it clear, students? Roll number A47, Rutuja Gaikwad. A47 roll number. B23. B division 23 roll number. Pratiksha. Yes, students, reply fast. Either tell yes, you have got the concept, or tell no, so that I can repeat. B division 74 roll number. Harshad. Have
Yes,
you
ma'am.
understood? Have you understood?
Yes, ma'am.
Okay. Right. So thank you, B78. Okay. So the finite automata is divided into two types, and to make the simple diagram we are using NFA, but NFA is non-deterministic in nature, and that's why may lead to multiple paths, and which will make the design complicated and time consuming, because with A I may reach to two states, so processing will be slower because I have to traverse both the paths. And to remove this difficulty, we are converting NFA into its equivalent DFA so that faster execution is achieved. So let us see how to convert it. Okay, so for that, for one example, we will take one example and we will start drawing the NFA for it, and then we will draw the equivalent DFA by using the algorithms. Okay, so for this same regular expression, let us start. This is the regular expression given, and I am going to draw the NFA first, and then I will draw the DFA. So for that, I will use the whiteboard. Okay. So we have already discussed that the regular expression given was A is compulsory followed by A or B star. Okay. Now we have seen this regular expression is given for specifying the tokens. So we are going to specify the tokens with it, and we are going to have the finite automata to recognize the tokens. So for finite automata, I will draw the NFA first for this expression, because drawing NFA with null is easy for me, and then I will convert it into its equivalent DFA. So NFA with null moves, I will be drawing the diagram. So as A is a simple or A is the compulsory variable, we can say. So I have the diagram for a single variable, like I will start with initial state Q0, and so initial state is represented with arrow encircled. So here Q0 is the initial state and A is the symbol. So with A is the compulsory symbol. So I'm going to reach to state number Q1. Okay. Now this with A, I'm reaching to Q1. Now once A is Pranav Dongre, check your mic. So here we are having compulsory path from Q0 to Q1 with A as an input. And after this, once A is found, you can have any combination of A and B with clean closure. So I can say that whenever the clean closure is there, you have to form a loop. You have to remember, whenever the clean closure is there should be a loop. So I will have with A or with B, I will reach to Q1. So this is my simplest finite automata. Now, if you see this diagram, you may say that this is the DFA only. This is DFA only, right? But in this example, it is true that it is a kind of DFA, but I may introduce the null transitions anywhere. So that diagram will be a different one. So I can say here, for this diagram, I may have initial state as Q0. Then from Q0 with A input, I will be reaching to Q1. Then from Q1 with null move, I may reach to Q2. And then Q2 can become the acceptance state, which will have any combination of, or instead of that, what we will do is Q2 also we will consider as one of the states, not final state, a non-final state. And Q2 will have a loop for A or B. And Q2 is again having the null transition, and you may reach to Q3, which is your acceptance state. Right, that is A is followed by any combination of A or B, and then you are going to reach to the acceptance state. So you may have this diagram, Q0 with A, Q1 with the loop A comma B, or you may have this particular diagram. So both are NFAs. So we are finding it simple to draw the NFA with this particular method. Now this NFA, I need to convert it into DFA. So I will draw the DFA for it. So converting NFA into its equivalent DFA is called as subset construction algorithm. The method from conversion of NFA to DFA is called as subset construction. So this method is called as subset construction method. Okay. Right. So this is our subset construction method in which we are going to convert the NFA into its equivalent DFA. So let us start the procedure. So for that, we should know the transitions from every state with every possible input variable. So for that, I will draw the board for the table first, where the table indicates the states and their transitions. So here is number of states are written, and here the input symbols are written, and then the blocks shows you the move possible with the input variables. So there are 4 states, Q0 to Q3. So I will denote it in the table form. So this is your Q0 state with epsilon move, with A move, and with B move, because these 3 are your input parameters. Then with Q1, with Q2, and Q3 is acting as your acceptance state. Okay. Then next. So Q0 with A, you are reaching to Q1. So Q0 on A, the entry is made in the table as Q1, while Q0 with null, no explicit entry is there from Q0 with null, but from Q0, if I want to remain in the Q0 itself, then I am applying no input. And that's why it is said that if I am applying null input, I am reaching to itself. So in short, as no outward edge with epsilon is present from Q0, I will remain in the Q0 only if no input is provided. So Q0 with null, I am reaching to Q0 itself. Right? All of you are getting that Q0 with no input. Jar inputच provide नाही केलं तर I will be there in the same state. And that's why Q0 on null, it will reach to Q0 itself. Then Q0 on B, there is no move specified. Then comes Q1 on null. So Q1 on null, I am reaching to Q2. So Q1 on null, I am reaching to Q2. Q1 on A directly, there is no move. Q1 on B, there is no move. So from Q1 with epsilon, I'm reaching to Q2 with explicit transition, and I can reach to Q1 itself. Q1 मधून मी एकही null transition नाही apply केलं तर मी Q1 मध्येच राहते. So Q1 with null reaching to itself, and it is also reaching to Q2. So explicit transition is present, and implicit transition gives you Q1 itself. So Q1, Q2 are the 2 transitions present with null move. Then there is no move with A and B possible. Then Q2 with null, there are 2 moves possible. From Q2 with null, I am reaching to Q3, and from Q2 with null, I am reaching to Q2 itself. So Q2, Q3, and from Q2 with A and B, I am reaching to Q2. So Q2 with A reaching to Q2, Q2 with B reaching to Q2. Now from Q3, there is no AB transitions. Only there is one transition, that is with epsilon, it is reaching to itself. So Q3 will reach itself with null move. So this is the table that we have drawn by using the automata. Now let us use the steps of the subset construction method. So subset construction method tells you that you have to assume the initial state as the first set of DFA. That is your first step, that the initial state of NFA is also one state of DFA. So I will start with Q0. So Q0 is my first state. Q0 is the first state. And then I have to check the moves of Q0 with A and with B. And here I have to remove the epsilon transitions because in DFA, you don't have the null transitions. We have seen DFA is having only deterministic path, no null transitions are present, and with single input, we are reaching to only one state. So for that, we should remove the null transitions. And that is done in this manner. If I want to check the transition of Q0 on A, then you have to go with the epsilon closure of epsilon closure of the transition of epsilon closure of Q0 with A. Okay. So the transition, this transition is from DFA. DFA मधली एक transition मला काय find out करायची असेल तर मला काय करावं लागेल? Epsilon closure. Epsilon closure म्हणजे काय? So the states which are reachable, close. The states which are close with epsilon as an input. So epsilon closure means the states which are possible by considering the null as an input. So we are going to find out the epsilon closure for this Q0. Okay. So we will see what is the transition of epsilon closure of Q0. So I will solve the inner bracket first. The inner bracket says epsilon closure of Q0. So what is epsilon closure of Q0? Epsilon closure means the moves possible from Q0 with epsilon as an input. So from Q0 with epsilon as an input, I am reaching to Q0 only. So this outer part as it is. So epsilon closure as it is. Inside that, this transition is also as it is. Only this epsilon closure of Q0, I am going to replace with Q0 here. So I will have Q0 on A. Okay. So what I have done, all the epsilon closures of Q0, I have taken here. As here only one entry is there, Q0 only. So I have taken only one entry. So whenever the epsilon closure of Q1 will be there, then at that time you have two entries, Q1, Q2, and you have to replace this bracket epsilon closure of Q1 by Q1, Q2. Okay. So that way I have taken the epsilon closure of Q0, it is Q0. Now I will check the transition. So the transition of Q0 on A. So the transition of Q0 on A is Q1. So I am reaching to the solution of this bracket is Q1. Transition of Q0 on A. Transition of Q0 on A is Q1. So I am writing here Q1 and the outside epsilon closure as it is. Now what is epsilon closure of Q1? Epsilon closure of Q1 is Q1, Q2. So ultimately, I am going to get the state Q1, Q2 as my new state. Okay. So in DFA, I have started with Q0 as my initial state, and with A, I am reaching to Q1, Q2 as my resultant state. That is Q1, Q0 with A, I am reaching to Q1, Q2. Now, as this new state is encountered, so I'm going to call this as capital A state. Capital A indicates the DFA state. So I'm going to indicate with capital A. Now this process you have to repeat, finding out the transition with new states. So you have to repeat this step till new states are getting generated. आता इथे एक नवीन स्टेट मिळाली आपल्याला Q1, Q2. जोपर्यंत नवीन स्टेट अशा मिळतात तोपर्यंत ही प्रोसेस तुम्हाला रिपीट करायची आहे. सो आय विल हॅव द सेकंड ट्रान्झिशन या स्टेटच Q0 with B. So what is the output you are going to get with Q0 on B? The same formula I will be using. So here the epsilon closure of transition of epsilon closure of Q0 on B. So Q0 चे ट्रान्झिशन चेक केले, दोन इनपुट आहेत आपल्याकडे A आणि B. So Q0 चे ट्रान्झिशन with A and with B I have checked. I will solve this and I will check whether any new state is getting generated or not. So solve this. Epsilon closure of Q0, epsilon of closure of Q0 काय होतं मगाशी आपण पाहिलेलं होतं. Epsilon closure of Q0 is Q0 itself. So I will have the solution for this particular step as Q0 only, and I will move with B. Q0 with B काही transition आहे का तुमचं? काहीच transition नाहीये. Q0 on B there is no transition. So you will have null move here because transition of Q0 with B is not there, and that's why I'm not getting any new state generated. There is no path possible. So Q0 बरोबरचे transition संपलेत. Now I will start with the transition with capital A because capital A is the subset that we have got. With subset construction method, we have got Q1, Q2 as the subset which is present in the DFA. So that next I will have the transition of capital A state with small a, and I will have the transition of capital A with small b. मग हीच स्टेप तुम्हाला परत by using the same formula I will repeat this whole process till new states are getting generated. जोपर्यंत नवीन स्टेट मिळतात तोपर्यंत तुम्हाला हे सगळं रिपीट करावं लागेल. And that is your subset construction method. So I will write here the epsilon closure of transition with epsilon closure of state काय A म्हणजेच तुमची Q1 Q2 state आहे. So epsilon closure of Q1 comma Q2 with A. Okay. So what is epsilon closure? Inner bracket पहले मी solve करती है. Epsilon closure of Q1 Q2. What is epsilon closure of Q1 and Q2? So you can see Q1 चा epsilon closure आहे Q1 Q2 आणि Q2 चा epsilon closure आहे Q2 Q3. So it is the union of both because whenever I am taking the epsilon closure of Q1 comma Q2, the meaning is you have to take the union operation. So I will have the epsilon closure of the transitions. The solution of this bracket epsilon closure of Q1 Q2 is Q1 Q2 Q3. And this A as it is. So what happens with the Q1 Q2 Q3 with A? So Q1 Q2 Q3 with A Q1 with A, null. Q2 with A, Q2. Q3 with A, no transition possible. So the solution of this bracket is Q1 with A, no transition, union Q2 with A is Q2, and Q3 with A is again no transition. So I will have the solution of this bracket as Q2 only. So I will have epsilon closure of Q2. So what is epsilon closure of Q2 now? Q2 चा epsilon closure काय आहे? Q2 Q3 आहे. So I am getting a new state Q2 Q3, which I will call it as capital B, which is the state of DFA. पहिले A मिळाली, which is Q1 Q2 चं combination. आता मला Q2 Q3 चं combination मिळाले, which is my state B. Now capital A with small b you have to check. म्हणजे जेव्हा नवीन B मिळाली आहे तेव्हा परत एकदा मला ट्रान्झिशन्स चेक करावे लागतील. Transitions of capital B with small a and transition of capital B with small b. मग हेच फॉर्म्युले सगळीकडे वापरणार मी epsilon क्लोजरचा, and I will find out the new state is getting or not. So this is remaining A with B. So I will write here epsilon closure, the formula of transition with epsilon closure of Q1 Q2, because A, capital A is our Q1 Q2. So it is the epsilon closure of Q1 Q2 with B. So what is epsilon closure of Q1 Q2 inner bracket? It is giving me Q1 Q2 Q3. So this bracket is giving me the answer as Q1 Q2 Q3 with B. This transition you have to check, and out of the bracket you have always epsilon closure. Okay. So transition of Q1 Q2 Q3 on B. Q1 Q2 Q3 on B. These are the three transitions. Union of these three is giving you Q2 only. So epsilon closure of Q2. So what is epsilon closure of Q2? We have already received that, which is your Q2 Q3. And this state already defined capital B. So now with capital B with small a, capital B with small b, we will check the transitions. So I will directly write down here the epsilon closure of transition of epsilon closure of B with A. So epsilon closure of B म्हणजे Q2 Q3 आहेत. Q2 Q3 ची epsilon closure काय आहे? तर Q2 Q3 च आहेत परत. So I will have directly, I will write down directly Q2 Q3 बरोबर A transition. So Q2 Q3 with A, Q2 Q3 with A is this. Q2 only. आणि Q2 चा epsilon closure काय आहे? Epsilon closure of Q2 हे already B state मिळालेली. Epsilon closure of Q2 is Q2 Q3. Q2 Q3 म्हणजेच तुमचं capital B आहे, which is already derived state. And B with B we will check now. मग epsilon closure of transition with Q2 Q3 आलाय, because epsilon closure of capital B is Q2 Q3 only. With small b, again Q2 is received. Q2 Q3 बरोबरचं B बरोबरचं transition is Q2. So I will have again epsilon closure of Q2 जी ऑलरेडी अवेलेबल स्टेट आहे बी. मग हे सगळे ट्रान्झिशन झाल्यानंतर तुम्हाला नवीन कोणती स्टेट मिळतीये का? नो. I am getting only Q0 as my initial state, capital A and capital B as the state of DFA. ह्याच्यानंतर further state कुठली derive नाही झालेली. So I will draw the equivalent DFA for this diagram as Q0 is my initial state. From Q0, the transitions are Q0 with A. Q0 with A, I am reaching to capital A. Q0 with A, I am reaching to capital A. And Q0 with B, there is no move. Then capital A transitions. Capital A with small a, I am reaching to capital B. You can check transition of A on A is B. And transition on A comma B is also B. So I will have A with B, both capital B. And from B, with A and with B, I am reaching to itself. So there is a loop. I will have A comma B. And what is the acceptance state here? So the acceptance states are initial state तर जी initial state तुमची NFA ची असते तीच तुमची initial state DFA ची असते. But for final state Q3 ही तुमची final state होती NFA ची. We have drawn the diagram in which Q3 was our acceptance state. So the subsets which has Q3 as the element, जे subset ज्याच्यामध्ये Q3 element आहे, that all are your final states of DFA. मग ह्याच्यामध्ये बघा Q0 तर नाहीच आहे. A मध्ये आहे का Q3? A मध्ये Q3 नाहीये. So A will not be your final state. Then Q3 is there in the state number B. State number B म्हणजेच काय? Q2 Q3 आहे. So Q3 is there in the state number B and that's why B becomes your acceptance state. Okay. So in that way, we have removed the epsilon transitions from NFA and we have converted it into its equivalent DFA. Getting it, all of you? Yes, students? Yes, students, reply fast. Whether you have got the procedure. A division roll number 3, Prapti. Prapti is there. Roll number 16, A division, Apurva Kadam. Roll number 6, Vedangi.
Yes, ma'am.
Okay. So, is there any difficulty?
No, ma'am.
Okay, thank you. So let us revise once again that for any regular expression we are writing, we are going to specify the tokens. And for any finite automata we are designing, we are going to recognize the tokens. So as we are going to recognize the tokens, the finite automata is always called as language recognizer because it is going to recognize the tokens generated out of the language construct. And that's why finite automata is also called as language recognizer because the job of it is to recognize tokens. Then once the regular expression is given, first thing is we are going to draw the NFA for it because it is easier to draw the NFA. And then drawing is easy, but processing is difficult because the path is not fixed for the input variables. So you may have multiple paths and which will lead the higher processing time. So instead of that, once the NFA is drawn, we are going to convert it into its equivalent DFA so that the processing will be faster. So that are the steps to convert the NFA into its equivalent DFA, and that method is called as subset construction method. So the question may be asked, any regular expression will be given to you, and the question is like, with the help of subset construction algorithm, design the or draw the DFA for the given regular expression, like that. So you should be able to do all those things. Okay. So let us move towards the slides again. So we are already knowing this behavior of the automata, that with whenever we are reaching to the final state, then the language is getting accepted with the given input string. So here sigma star indicates the multiple input symbols, number of input symbols with starting state Q0. If I am reaching to the acceptance state, then it is considered as the language accepted. And if we are not reaching to the acceptance state, then the token is not getting generated. Then the language is called regular. So as we know that this the finite automata is generated with regular expression. So regular expression generates the regular language. So if regular language is there, then we are able to draw the finite automata for it. So always remember, whenever the language is regular, then it is accepted by finite automata. Then let us see how finite automata plays important role in lexical analysis. So yesterday we have seen that in order to draw or in order to write the pattern for any C programming construct, we are making use of finite automata. काल आपण बघितलं comment कशी लिहितो. So for writing the comment also, we are making use of finite automata. Similarly, for writing the if else loop, for writing the for loop, or for writing the function calls. So we have a specific pattern which is always represented in finite automata. So here the tokens of language are specified using regular expressions. So we have already discussed that specification is always done with a regular expression. The scanner is a big DFA, essentially the aggregate of the automata for individual tokens. So in the yesterday's example, we have seen the relational operators. So we are considering all the relational operators with one finite automata only. Less than, equal to, greater than, equal to, or equal to, three possibilities. less than, greater than, and equal to. All the three cases we have observed by using the single finite automata, and it is mentioned here that you have to aggregate. आपण त्या diagram मध्ये काय केलं होतं? I will show you that diagram so that, yeah, here. So what we have done, we have aggregated the different tokens. एक टोकन होतं आयडेंटिफायर, दुसरं टोकन होतं इंटीजर, तिसरं टोकन होतं ऑपरेटर ग्रेटर दॅन and operator greater than equal to. So I have combined all those four paths. I have aggregated those four tokens to generate the equivalent finite automata. So it is a big DFA which essentially aggregates the automata for individual token. इथे एक individual token आहे identifier, एक individual token आहे integer. So I am combining all those things to generate the big DFA. Now, what are the issues in drawing these finite automata or designing the lexical analyzer? So the issues are, what does the scanner automata look like? So first issue is, you should be caring about the syntax of that scanner or the lexical analyzer, or we can say the finite automata. How much should we match? In yesterday's example, we have seen how much we should match. If we leave in between, पहिले एक स्लॅश आणि स्टार आहे कमेंट मध्ये, and then we will stop. एवढंच मी चेक केलं की स्लॅश आणि स्टार आहे, and I will not check, I am not going to check the further, then it will not be considered as a comment, right? So how long we should go for a match, that is also the question. मी कुठपर्यंत चेक करत जायचं की हे बरोबर आहे का? So that is again the concern or issue. How much should we match? When do we stop? That is one of the issue while designing the lexical analyzer. What do we do when a match is found? Then a specific action. जेव्हा एखादा token, whenever you are going to get any token, what is the corresponding action specified that you have to consider? Because when the comment is encountered, then you have the action like neglect that comment, because it is the job of the lexical analyzer to set out the comment, separate out the white spaces, enter characters, tabs, etc. So if comment is encountered, you are going to neglect it. But if any if loop or for loop is there, then you have to consider that while executing the program. So depending upon the construct, जेव्हा जेव्हा match found झालंय, then which action you have to take, that is the main issue under consideration. And then next is buffer management. So efficient use of buffer should be done so that minimum space is required and you can get the token generation process in minimum time also. So time and space complexity is considered in buffer management. So these are the four issues while designing the lexical analyzer. So this is, we have seen that the scanner automata, it is the bigger DFA which aggregates the smaller automatas, small finite automata are combined to generate the big DFA. So this is the transition diagram we have seen yesterday. The transition diagram we have already covered yesterday. So it is also generating number of tokens. So all those are combined together, aggregated together to form a big DFA. Then second is how much we should match. So we have to find the longest match possible. The example is, consider consider a program, a C program in which I have a variable int calculate and I have a function called user defined function calculate 1. It is a function call. Okay. So the example is I am having one integer variable calculate. The name of the variable is calculate. And I have a function called calculate 1 opening closing bracket. Now, if from this line, if I will go on reading up to calculate only, मी फक्त calculate पर्यंतच read केलं तर काय होईल? Instead of a function call, it will consider this as the integer variable because token match झालेलं आहे. मला मिळालं की calculate हे already defined एक integer variable आहे. So instead of a function call, it will start working as a variable. But whether it will give me the proper output? No. So for that, what I should do is I should go with the longest match possible. जर मी पुढे तसंच मॅच करत गेले आणि मला ओपनिंग क्लोजिंग ब्रॅकेट सापडलं, then I will realize that yes, it is a function call because opening and closing brackets are involved. जर मी इथेच स्कॅनिंग त्याचं थांबवलं असतं तर मला डेफिनेटली टोकन मिळालं असतं, एरर तर जनरेट झाली नसती. But I may not get the proper output as per my requirement. So it will start detecting the further characters and it will treat that calculate as a integer variable. But it will not give me the proper or desired output, and that's why we should always find the longest match possible. मग लॉंगेस्ट मॅच जर मी बघितलं तर काय झालं, हे ओपनिंग क्लोजिंग ब्रॅकेट मिळालेत आणि मग मी सांगू शकते की दिस टोकन इज अ फंक्शन कॉल. So this is your function call, user defined function. Okay, so that is considered as the longest match. The second example shown here is input 1 to 3.45 if it is given. Then if I am going to consider this as a number constant, then it will consider only integer variable 1, 2, 3. But the fractional part it will not consider. So for that, what I have to do is I have to go with the longest match, that after fractional also you have some digits and that will give you the proper number. Right? So here, instead of going with only integer part of this number, I have to concentrate on the floating part also or fractional part also. And that is giving you the longest possible match. Okay. So these things you have to consider while designing the lexical analyzer generator. Okay. So that was the different issues while considering the lexical analyzer. So we have considered the three main issues. First is you have to go with the efficient buffer management, time and memory management. The second is you should combine the smaller finite automata to get the larger finite automata, which is acting as the main scanner, which is the big DFA we can call, and that will act as a scanner or token generator. And the third is we should go with the longest match so that we can get the desired output. So these three things we have considered while dealing with the finite automatas and design of the lexical analyzer. So let us see the next bit, which is the last bit of this second number chapter, which is the lexical analyzer generator. So this lexical analyzer generator For that, we are going to make use of Lex tool. So it is same as that of your C editor, but it has different programming construct. It has different programming construct. So we will learn this construct during the practicals also. This is our first practical where we are going to provide one input to this program, and we are able to generate the tokens. Okay, so let us see how this Lex tool works. So what is the normal process, or what is the working of a C program? Whenever you are writing a C program, you are saving it as .c extension with .c extension, and then you are going to compile it and execute it. So what changes are taking place during the compilation and execution of a C program? Can anyone tell me? Yes. लिहिलाय का कधी C program? Yes, tell me. The source program you are writing in a C language. Name of the program is suppose abc.c. abc.c नावाचा एक मी program लिहिला. This is the program I have written in the C. Name I have given as abc.c. Then, once you store this program as abc.c, what is the next step you are carrying out? You are compiling that program to check the errors. Compile केल्यानंतर तो program कशात convert होतो? After compiling, abc.c is getting converted into yes. So we are converting it into the object file. It is getting converted into obj. If you observe your TC folder, then there are multiple obj files. And after performing the, running this obj file, we are going to get the executable file, and we are going to execute that file and get the output. This is the normal flow of a C program. That first C program we are writing, then compiling, getting the object code, then the object code is executed to get the output. So this is the normal C programming structure. Similarly, Lex is also one tool, and Lex has its own routine, or we can say the steps to execute a Lex program. So this is the lexical analyzer generator Lex. Here the source program is stored with .l extension. Always remember. You can write here any file name abc.l, pqr.l, anything. So first, whenever you are writing the file in the editor, it is getting stored as .l. So in C, we are having the .c extension. Here in the Lex program, the Lex source program is always stored with .l extension. Then you need to first compile it by using lexical compiler, because it is having two types of compiler. First, .l program, you have to convert it into a .c program. Additional step is required here because we don't have the .c program with us. We have the Lex file with us. So that Lex file is with .l extension, It has its own compiler, which is called as lexical compiler. And after first compilation, this is your first compilation, then that .l file will get converted into lex.yy.c. So it is the default name given to the file. Always you have this file name only, lex.yy.c. Okay. So whenever I am writing the lex.l file, it is converted into lex.yy.c by performing the lexical compiler. Now we have equivalent C program with us now. .l होता त्याला मी कन्वर्ट केलं .c मध्ये, तो आता माझ्याकडे .c प्रोग्राम आहे. Next I have to compile it in the C program. Compile it as a C program with C compiler. पहिले lexical compiler केलं, C मध्ये कन्वर्ट झाला. आता C compiler केल्यानंतर now you will get this a.out which is your object code. आता काय केलेलं आहे मी, C program compile केला परत C compiler मी, and then I am going to get the object code. And once I will get this object code a.out, ह्या फाईलला मी इनपुट स्ट्रीम पास करणार आहे. आणि त्या इनपुट स्ट्रीम मध्ये काय असणार आहेत, डिफरंट टोकन्स, जे मला टोकन्स जनरेट करायचे. सो एनी सी प्रोग्राम, कुठलाही एक सी प्रोग्राम आहे, printf hello वगैरे एवढं असं लिहिलेलं. So that C program I will be passing as an input to a.out file, object file. Then from this program, जे काही असेल याच्यामध्ये printf hello, those tokens are getting generated as output. So या C program मध्ये जे जे तुम्ही tokens use केले असतील, integer a जर मी define केला असेल, तर integer is considered as keyword, a is considered as the identifier. हे सगळं तुम्हाला tokens generate होऊन येतील. So this is the process how we are going to generate the lexical analyzer. All of you are getting it? Yes. This process is very, very important. That first we are writing the .l file as lex source file. Then as it is written in the lex format, you need a lex compiler. So that compiler will convert that .l file into .c file. Then once the .c file is with me, I can compile it again with C compiler so that the object code will get generated. So a.out is the object code always getting generated. And once you are going to provide the input to that a.out, the tokens are getting generated from the input stream provided. Right? So this is the whole procedure of the lexical analyzer generator. Now what to write in this lex.l, that we will see. Steps आपण compile कसे करायचे हे आपण आता learn केलं. But what is the source code in this lex.l, that we will learn. Up to this, is there any difficulty? Yes, students. All of you are getting this procedure. Lexical compiler, then C compiler, and then the object code is provided with the input stream, and you are able to get the sequence of tokens as output. Okay, so let us see the code for lex.l. आता lex.l मध्ये मी काय लिहिणार आहे जेणेकरून मला tokens generate होऊन येतील. So this is the structure of a lex program. So the structure of the lex program is divided into 3 parts. First portion is called as declaration. It is separated with the second section, which is called as translation rules. So first section is declaration, where we are going to declare the variables required. It is separated by double % sign from the translation rules. these rules have a specific syntax. The syntax is, first you have to write pattern, followed by you have to write the action. If this pattern is found, what action to be carried out? So this is translation rules. Then the third section is auxiliary functions. Again, translation rules and auxiliary functions are also separated by means of double % sign. So syntax of the LEX program is like this. First, declaration portion, double % sign. Then second section is translation section or translation rules. Those rules are specified in the form of pattern action. And then again, double % sign, and you will have the function, auxiliary function, that is the main procedure of the LEX program, main function call. Okay, so the example given here is, this is your declaration section. The declaration section is always specified. If suppose these declarations you need in your C program also, because what is happening, we are storing this whole file as a .l. We are going to store this whole file as .l, which is going to convert it into .c. But whenever I am using this .c file, at that time when I need these declarations, then they are specified like this in the % opening bracket, % close bracket. Meaning is, those variables I may need to use in the .c. And if I am writing without specifying this % opening, % closing, if I am writing it here directly, then they are used in the local file .l. जेव्हा मी इथे लिहिते या दोन ब्रॅकेटच्या मधले व्हेरिएबल्स जे आहेत ते .c मध्ये मला यूज करायचे म्हणून मी लिहितेय. जर मी हे दोन म्हणजे % ओपनिंग, % क्लोजिंग हे जर टाकलं नाही, तर जे मी व्हेरिएबल इथं डायरेक्टली राईट करतेय ते व्हेरिएबल्स मी या फाईल मध्ये, लोकल फाईल मध्ये यूज करणार आहे. ओके, सो this is the difference between the two declarations. One declaration used for the C program and second declaration used for the local .l program. Okay, then so these are the regular definitions. ह्या ज्या definition आहेत त्या मी .l मध्ये use करतेय. So I am writing these definitions over here, and inside this bracket, whatever I am writing, that I will be using in my .c after one compilation. So these are the definitions. What is the delimiter? Delimiter is specified in this manner. Delimiter म्हणजे space. So space can be a tab or it can be a new line character. जेव्हा दोन्हीपैकी काहीही मिळेल, one occurrence. Square bracket म्हणजे आपल्याला माहिती आहे, square bracket म्हणजे one occurrence of this, either /t or /n or both. So if it is occurring, then we are calling it as a delimiter. So the definition of delimiter is /t/n. Then white space, WS stands for white space. So if I am finding multiple delimiters, then it is going to consider it as a white space. Multiple means positive closure it is considered. So if one or more delimiters are there, then it is considered as white space, one or more. Then it comes letters. So letters are specified as capital A to Z or small a to Z, one occurrence. Digit is considered as 0 to 9. So we have already described all those definitions. Identifier is specified as letter followed by letter or digit, many occurrences. Number, it is followed by at least one digit, followed by you may have the fractional numbers, or you may have the exponents, that is the real and imaginary numbers and all those things. So it is the overall definition of any number. So e to the power we have some numbers like e to the power, so they are considered as imaginary numbers or exponents using that. So these are the definitions I will be using in my local program. So you can see here, this number I'm using over here, the ID I'm using over here, right? And the if then else, so I'm using this if then else in my C program, and that's why they are written in this percent opening, percent closing. Okay, so this is how, and always remember that this is your declaration section. This was your declaration section, first declarations. Some declarations are used in the C program and some declarations are used in the .L program. Then it is separated by double percent sign from the rules section. So rules section is always written in pattern and action form. So this is pattern. Pattern is what? If white space is encountered, this is the pattern, white space. What is the action? No action or no return. जर व्हाईट स्पेस असेल तर इग्नोर करायचं असतं, निग्लेक्ट करायचंय आपल्याला लेक्सिकल अनालायझर मध्ये, अँड दॅट्स वाय देर इज नो ऍक्शन अँड नो रिटर्न. ओके, इफ असेल प्रोग्राम मध्ये लिहिलेलं तर हे रिटर्न इफ करायचे, पण ते रिटर्न कुठे होईल? सी प्रोग्राम मध्ये रिटर्न होईल. तसंच देन एल्स सेम काइंड ते सी मध्ये रिटर्न होतील, कारण दे आर युज्ड इन द declaration section of a C program. Then comes identifier number. So if ID मिळालं मला, तर ID मध्ये काय करायचंय मला? ID मिळालं, that is in my program I have reached, suppose I have written integer num. So it will find this as ID. Because ID चा format काय? It should start with letter followed by any combination of letter or digit. So it is giving me the same format of ID. एखादा ID मिळालं तर काय होईल? त्याची value you have to store. That value you have to store. Because I may use this num variable further in my program. मला हा नंबर डिस्प्ले करायचा असेल किंवा इन्क्रीमेंट करायचा असेल किंवा डिक्रीमेंट करायचा असेल, तर त्या केसमध्ये एखादा आयडेंटिफायर मिळाल्यानंतर त्याची जी व्हॅल्यू असेल, सो यू आर गोइंग टू स्टोअर दॅट व्हॅल्यू. YYLVAL means it is the syntax for that value of that identifier. So it will store that value into YYLVAL. Okay, so that is done for any identifier, any number. जरी नंबर कुठला मिळाला मला, एखादा नंबर मी स्टोअर केला असेल 123.45, then it is going to match with the number pattern. The number pattern digit plus 123 plus point digit, point again digit. So it is matching with this number pattern. So what is the corresponding action you have to take? You have to install that number, that is you have to copy that number and store its value into the symbol table for further use. And then you have to return that number in your C program, because it may be used in the calculation of C program also. So similarly, ID and number you have to return into the C program. So in that way, you are writing the translation rules section, and then it is again further followed by the double percent sign, which indicates the end of the translation section, translation rule section. And next you will have the function section. So whatever the functions you want to carry out, they are written here. So whatever the main function is there of this lex file, this is your lex file. So whatever the functions are there, they are written in the auxiliary functions. Okay, so this is the structure of a lex program. All of you are getting the structure of the lex program? Yes, students. A division rule number 12.
Yes, ma'am.
Okay, you have got the structure of this Lex program.
Yes, ma'am.
Okay, thank you. So, in detail, we are going to learn this lexical analyzer generator during the practicals. But you should remember these things, that the declaration section is there, followed by the translation rules. They are having this particular format, and followed by the auxiliary functions. And the separation is done with double percent sign. So we are going to write this L program, .L program, and we are going to run it, and we will be generating the tokens. So the job of lexical analyzer is done with this .L program. Okay. So this ends with your chapter number 2, the program related with the lexical analyzer generator that we will see in our practical slot. Okay. So the chapter number 2 is also over. So we will have the MCQ test on chapter number 1 and 2 combined. So in the next lecture, maybe I will be giving you the link. You have to appear for the MCQ test on chapter number 1 and chapter number 2. Okay. So we will stop here for today. All the participants, you have to enter your attendance only once in the chat box. And if you have any doubt, you can ask me from this chapter number 1 and chapter number 2. If you have any doubts, you can ask. And once you finish writing the attendance, you may leave. Thank you. Write attendance only once. If you have any doubts, you can ask.